In example 7, we're asked to divide a cubic polynomial by a linear polynomial and then show that 4 is the only real root of f of x equals 0. Okay, so we need to start off by doing the algebraic division. Okay, and dividing by x minus 4. So x into 3x cubed is 3x squared. 3x squared times x minus 4 is 3x cubed minus 12x squared. And when we subtract them, we get 0 and 0. So we need to bring down two terms. We have a 6x minus 24. And start again. X into 6x is 6. 6 times x is 6x. 6 times minus 4 is minus 24. So we get a remainder of 0 when we subtract them. And that shows us that x minus 4 is a factor. So our cubic we can express as the product of this linear factor and this quadratic. So that is f of x. Let's just write that down. Okay, so f of x is equal to x minus 4 times our quadratic 3x squared plus 6. Okay, so part B. In part B we have to show that 4 is the only real root. Well, when they talk about real roots in the exam, what they mean is the solutions to either y equals 0 or f of x equals 0. So basically, where does the curve cross the x-axis? Those are the roots of the equation. So if we set f of x equals 0 and then solve this equation, we'll get the roots. And it's actually quite easy. Once it's factorized, it's easy to work out what the roots are. That's the whole point of factorizing, to work out where the curve crosses the x-axis, or finding the roots of the equation. So either one of these two factors can be 0, and you can see from the first factor, if we write down x minus 4 equals 0, that leads to x equals 4. That's what we're given in the question. Okay, so we know that one is true, hence show that 4 is the only real root. Well, it certainly is one root. Now we need to show that there is no other roots. So if we set the other factor equal to 0, that's going to lead to x squared is equal to minus 6 over 3. If you rearrange it for x squared, you get that, which is minus 2. And then take the square root, you get plus or minus the square root of minus 2. Now, if you're doing further maths, you'll recognize that as having complex roots, but no real roots there. For those of you doing regular maths, you shouldn't end up with the square root of a negative number. And if you do, then you simply write down no real roots. Okay, or no real solutions. Of course, another way to do it is to look at the discriminant of our quadratic equation. So if you write down the coefficients, there's no x term in this quadratic, so b is 0, c would be 6. So the discriminant is b squared minus 4ac, and in this case it would be 0 squared minus 4 times 3 times 6, which is minus 72. Okay, so we have a negative discriminant, which again means that there's no real roots to that equation. Okay, so either method, just rearranging it for x, or using the discriminant to show that there's no real roots. Okay, so the only real root is x equals 4. Okay, a little task for you now. Here we've got 4 cubics, and what I'd like you to do is to See if you can factorize them fully. Can you sketch the curves? If they don't factorize fully, what do those curves look like? I'll be going through these in our face-to-face tutorials. Once you've done them, folks, have a go at the rest of exercise 7b. Should have done question 1 now, so have a go at questions 2 to 7 on page 141. And again, we'll go through those in our tutorial session.